Hello everyone, welcome back to Smart Interviews YouTube channel. I am 𝗥𝗲𝗃𝗃𝗃𝗃. Let's start with the second problem of biweekly contest 137. So here you're given a array nums of length n and a positive integer k. You're given one property, the power of an array. So it is defined as the maximum element if all the elements are consecutive and sorted in ascending order. Otherwise, the power of the array will be -1. Okay. So you need to find the power of all the subarrays of nums array of size k. So there will be n minus k plus 1 subarrays you need to return in the form of array. Okay. So here, let's try to understand with an example. So here, how many subarrays are possible? Here the size of the nums is 7 and the k value here is 3. So there will be 1, 2, 3, 4 and 5 subarrays possible. So in the first subarray 1, 2 and 3, are they consecutive? Yes. 1 plus 1, 2, 2 plus 1, 3. And yeah, so this is consecutive. Are they in increasing order? Yeah. So I can say that the power of this array will be 3. Okay. When I go to other subarray 2, 3 and 4, is this consecutive? Yeah, 2 plus 1, 3, 3 plus 1, 4. Yeah, I can say this as consecutive. As is this in increasing order? Yes, definitely. So the power will be 4. Now, if I go to the other array, is this consecutive? 3 plus 1, 4, but 4 plus 1, it should be 5 here, but it's not right. So here, it's going to fail. So the power of this subarray will be -1. Let's try to understand with a better example. Okay, first of all, before we go to the other example, if we try to do this in a brute force way, that means iterating on all the subarrays and checking if it is consecutive and increasing or not. If you do this, there will be like n minus k plus 1 subarrays into inner iteration will take k times. This will be my complexity for brute force. Will this work? If I go to the constraints, I see that it's going till 10 power 5 and the same as k. So if I assume like my n is 10 power 5 and k is 10 power k, somewhere or the other, it's definitely bigger than 10 power 9. That means it will give you TL. So better, we should not try to implement this. Anyhow, we will definitely get TLE. Let's try to optimize our solution. For optimization, I will take uh, a better example. Let's say this was our solution 1, which will give us really. Let's say we'll consider the following array as an example nums. Okay, the array is like 1, 3, 4, 5, 4, 7, 8. Okay, this is my array. Here, if you check my expected output, my output should be like, and yeah, my k is here the same 3. So my output should be like, for this subarray, obviously it's increasing, but it's not consecutive. So it will be -1 here. For the next subarray, it's consecutive and increasing, so it will be the maximum element 5. Next time, 4, 5 and 4, it's, if you see, it's not consecutive here and not increasing either, so -1. So in this subarray 5, 4 and 7, they are not increasing and not consecutive, so -1. The same goes with the last, they are increasing, but they're not consecutive, right? So it will be -1. This is my expected output. Okay. So here, first understand the property of consecutiveness. So here, when can I say that the elements are consecutive? When my nums of j and nums of j minus 1, if the difference is equal to 1, I can say they are consecutive. Else, no. So understanding this, I will create one of the separate array. Let's say the array name is dp of size same as nums. So here, for the first one, I am not going to keep any value, so it will be 0. Now, I will check 3 with its previous number. 3 minus 1 is 2. Is it equal to 1? No. So, I will just mark it as 1 here. Okay. Whenever, if it is not equal to 1, I will just simply uh, keep my dp of j as equal to 1. Okay. Now, the same. 4 minus 3 is equal to 1. So, same 0. Uh, and yeah, you can ideally think that initially all are zeros. 5 minus 4 1, 4 minus 5 is obviously minus 1, so keep it here 1. Is it equal to 1? No. Is it equal to 1? Yes, so keep it same. And yeah, let's mark it this also in red. So if you observe, we have created one of the dp array where we got this as an output. What does the 1 indicate here? It's uh, it's a property where it's failing this consecutive condition. So keeping this in mind, now I will again iterate this time on dp array by keeping, like, in my subarray how many ones I have. Okay, so let me just iterate again on it. So I will declare a variable, let's say count. Okay, initially my count is 0. I will iterate first, since my k is 3. I will iterate on my first subarray, and how many ones I have here? 1. So obviously, what does this 1 tell? There is a number where it is not following this property. That means whenever my count is greater than 0, that subarray is invalid. So in my answer, I am going to keep it 1 minus 1. Okay. Now when I go to other subarray, this was my first subarray. When I go to the other subarray, or let me just represent it here. When I go to other subarray, 3 4 5. Why did we get this one? Why? Because this 3 was not consecutive for this one. But in this subarray, do we have 1 here? No, right? That means in such case, this one should not be considered. That means whenever uh, I will just move this up. That means whenever my this is my I here, right? Whenever my I minus k plus 1, so my I is here at 3 and my k is also 3. My I is here at 4 and my k is also 3. So this will be my I minus k plus 1. So whenever it is set to 1, I will just decrement the count. And whenever I have this, the incoming element as 1, I will increment. But here it's 0, right? So I will not increment the count. At this point, I have my count equal to 0. So my answer will be my array of I, my nums of I. So I will just keep it there. Now, when I go to other subarray, now do I have 1 here? No. So no decrement. Do I have 1 in the incoming element? Yes. So increment the count. Now at this point, my count is not equal to 0. So that means it's invalid. So simply keep just -1 and increment it. In the next subarray, was my outgoing element set to 1? No. So no decrement. Was my incoming element set to 1? Yes. So increment the count. Definitely it's not equal to 0. So it will be set to -1 and move forward for the next subarray. So here is the outgoing element set to is the new element set to 0? Yeah. So will not increment. But here 4 we have set to 1. So we'll decrement the count 1. But still my count is not 0. So I will place here -1. That will be the end. And yeah, our answer array is equal to the expected output. So let's try to implement this practically. Let's try to implement this practically. So first thing we need to declare the vector, our answer vector. We can just give a fixed size for it. The n is not defined. What is n? My num size. We also need our DP array. The DP array will also be of size n. So first initialize the values of DP array. If it is not following the property of nums I, and yeah, since we are comparing with I minus 1, I will start with 1. If it's not equal to 1, in that case, I will mark dp of I as 1. Okay. In the other cases, it will be 0. Now, I will start our main logic. I will declare a variable c. I will iterate first on the first subarray. That means I will iterate from 0 to k minus 1. And when I'm iterating, I will just keep the count of dp. If my dp of I is equal to 1, just increment the count. Otherwise, it will be same. After the first subarray, just check. If my c is equal to 0, I can initialize my first value with with my nums of I minus k. Else it will be -1. But this we need to consider for all the remaining subarrays. So my remaining subarrays will start from k and go till n. Every time I will check two conditions. If my the first element, that means if my dp of I minus k, okay, plus 1, if it is equal to 1, then I will do c minus 1. And the other condition is if my incoming element dp of I If it is equal to 1, then I will increment the count. Why? Because this is present in the subarray. And the regular condition follows. If my C is equal to 0, okay. If my C is equal to 0, then my answer of I, ideally my answer of I minus K plus 1 will be my nums of I. In the other cases, it will be minus 1. And then at the end, return your answer. Let's see if it works or not. Okay, one second. It will be ideally K minus 1. Why? Because I is not declared, right, outside. Let's try to submit it. Cool. If you check, our current code has the complexity of only big of n. The first for loop is taking n time. This for loop is taking k times. This is taking n minus k time. So in big O, our complexity is n. That's why we are able to get optimized solution. So that's it for this video, guys. If you want to learn more about such problems, join our Smart Coder course. For more information present in our description box. Check it out.